Neurodegenerative diseases affect the brain and nervous system. In neurodegeneration, neurons, the functional cells of the brain and nervous system, start to die off and are not replaced. Eventually, this leads to problems with the brain's ability to coordinate and respond to information, leading to problems with cognition, memory, or other bodily functions. Most forms of neurodegeneration are age-related, but some are genetic and can affect people of any age. Alzheimer's disease and Parkinson's are the two most common and best known neurodegenerative diseases. Both are age-related. Alzheimer's disease is probably the best known and most feared age-related disease. Alzheimer's is characterized by declining cognition and particularly by memory loss. This is because neurons, particularly in the part of the brain responsible for memory, start to die off. Why this happens is still an open question. Plaques of a protein called A beta and tangles of a protein called tau can build up in the brain with age. They have been implicated in the disease, but some researchers think they are a symptom rather than a cause of Alzheimer's. Even though A beta protein aggregates are toxic and lead to cell death, autopsies show that some people accumulate significant amounts of them without ever coming down with the disease. Alzheimer's has proven to be particularly difficult to treat, with hundreds of failed clinical trials and no effective treatments. Alzheimer's is typically a disease of the very old, though some familial forms can start younger. As the population of longer-lived adults grows, Alzheimer's is becoming more common, and the urgency to find effective treatments is growing. Parkinson's disease is the other most common neurodegenerative disease. It initially involves motor function. In Parkinson's, a protein called alpha-synuclein starts to build up in the dopamine-producing neurons in a region of the brain called the substantia nigra. These protein aggregations, called Lewy bodies, are associated with cell death. As the dopamine-producing cells start to die off, patients develop difficulty controlling their movement. Tremors, along with stiffness and difficulty initiating movement, are common symptoms. As the disease progresses, tremors become more severe, and there is a gradual loss of body function, including swallowing. There is no cure for Parkinson's. The most effective treatment for the disease was developed in the 1950s. Levodopa helps supplement the lost dopamine to slow the effects of neurodegeneration, but over time, the side effects of levodopa can be as troubling as the disease itself. Reducing or preventing the buildup of alpha-synuclein is one of the prime targets of therapies in development to treat Parkinson's. Some scientists strongly believe that Parkinson's disease begins in the gut and migrates to the brain over time. There's evidence that one of the first signs of Parkinson's is digestive issues like constipation. Neurodegenerative diseases are separate from normal brain aging. As we get older, the brain changes. This includes some loss of neurons. In fact, brain size decreases by an average of 5% each decade after 40, even in healthy people. Some things, like general mood and outlook, improve with age. Other factors, like short-term memory, tend to get worse. However, a healthy aging brain and a brain with neurodegenerative disease do share some general patterns at a cellular level. The difference is that neurodegenerative disease is identifiable by distinct molecular pathologies connected to progressive clinical symptoms that come to impair day-to-day function. At the molecular level, what is happening in neurodegenerative disease, and how are the hallmarks of aging implicated in the process? First, proteostasis is clearly implicated in Alzheimer's and Parkinson's. In both diseases, toxic aggregates of misfolded proteins build up and affect brain function. Also, mitochondrial dysfunction is found in Alzheimer's and Parkinson's. Less efficient mitochondria lead to energy deficits within the neurons, causing a decline in performance. Impaired mitochondria also produce more reactive oxygen species, free radicals, which damage molecules within the neurons, impairing their function. Cellular senescence has recently been recognized as a source of inflammation in the aging brain. Studies at the Buck have found that reducing senescent cells in the brain can reduce the effects of Parkinson's disease in mice. Finally, Alzheimer's disease is sometimes referred to as type 3 diabetes. Altered insulin signaling and glucose processing, specifically within the brain, has been closely associated with progression of the disease. People who have type 2 diabetes are at increased risk for all dementias.